Good morning, Makle. Good morning.
Good morning, ma'am.
Good morning, ma'am.
Good morning, all of you.
Good morning, ma'am.
Good morning, ma'am.
Good morning. Good morning,
ma'am.
children.
Good morning, ma'am.
Yes, good morning, all of you. How are you, Makle?
Fine, ma'am.
Fine, ma'am.
Fine, and you, ma'am?
Okay, good.
How are you, ma'am?
Okay, I'm also fine, Mole. Good morning, children. Welcome to today's class. Good morning. Good morning, all of you.
Ma'am, how are you, ma'am?
Oh, I am fine, Mole.
Good morning, ma'am.
Okay, good morning. Good morning, children. Good morning. Yes, good morning. Okay.
How are you, ma'am?
Oh, I am fine, Mone. What about you?
Fine, ma'am.
Okay.
Good morning, ma'am.
Okay, good morning. Good morning, children. Good morning, all of you. Today, you will be having a different type of learning. AR related class. It will be more interesting for you. You should participate actively. Okay?
Okay, ma'am.
Okay.
Okay, ma'am.
Okay.
Okay, ma'am.
Okay, Makle. Okay. Are you ready? Let us start.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Okay, here we are discussing about a geometrical topic. Understanding quadrilaterals. This is chapter number 3, Understanding Quadrilaterals. We are going to discuss a topic from this chapter. Are you ready? Are you ready?
Ma'am. Yes, ma'am.
Okay. Let us start. Okay. You had familiar with so many geometrical terms like point, line, line segment, angle, isn't it?
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Then, which is a basic unit of geometry? Anyone can answer?
Point.
Very good children, very good. Yes. Point is the basic unit of geometry. As you know, so many points all together to form a line.
Line, ma'am.
Yes, it is line. And the line segment, ray, all are the parts of a line. We know the line segment, line, all are the parts of a line. So here we are starting from lines. Which are the different types of lines? Here we can see straight line. These are straight lines. Then
Slanting line, sleeping line.
curved line. These are curved line. Can you see curved line?
Yes, ma'am.
Yes, these are curved lines. Can you see a circle here, Makle?
Yes, ma'am.
This is also curved line. A circle is made of one curved line. So two types of lines, straight lines and curved lines. But curves are classified into two types, open curve and closed curve.
Closed curves.
Yes, open curve and closed curve. These are closed curves, but here this one, these are open curves. Can you see? Two endpoints are there. In an open curve, there are endpoints, but in closed curve, there is no endpoints. In closed curve, we can see in a closed curve, there is no endpoints. It enclosed an area. Can you see? These are closed curves. There is no endpoints. Is it clear, Makle?
Yes, ma'am.
It enclosed an area. So two types of curves which are open curve and closed curve. Okay. Okay, then let us see some shapes in our surroundings. We can see so many geometrical shapes here.
Yes, ma'am.
Floor design. Yes, in this floor design, we can see so many geometrical shapes made up of straight lines. These are known as polygons. Polygon, the word polygon, it's a simple closed figure made up of only line segments. We can see so many examples here. Triangle. Yes, here in this pattern, we can see so many polygons. Can you see some polygons here, Makle?
Yes, ma'am.
These are made up of straight lines. These are closed figures made up of straight lines. So these are known as polygons. What? Polygons. Yes. So how can define polygon? Polygons are two-dimensional shapes. They are closed figures made up of only line segments. And the word polygon comes from Greek. Poly means many and gun means angle. Yes, angle. So polygon means many angled shapes. Yes. We can define polygon. How can define it?
Polygons are two-dimensional shapes.
Okay.
From the word Greek.
Very good, very good. Okay, Jeevan, tell me. Polygon
Yes, ma'am. Polygons are two-dimensional shapes. They are closed figures made up of line segments.
Very good. Polygons are closed figures made up of only line segments. Okay, see some figures here. Can you see a polygon here?
Yes, ma'am.
Yes, the first figure. Can you see the first figure?
No, ma'am.
This one is not a polygon. Very good, children. Here, the first figure is not a polygon because it is an open figure. It is not a polygon. But in the second figure, it is closed figure. But can you see a curved?
It has curved
So it is very good. Very good. It is also not a polygon because it is a yes, there is a curved side. But in the third case we can see
polygon.
yes, it is a polygon. It is a polygon. It is a polygon because it is a closed figure made up of only line segments. Yes. So it is a polygon. As per the definition, polygon is a closed figure made up of only line segments. Is it clear, Maklai? Is it clear this concept? Okay.
Yes, ma'am.
Okay. Let us classify the polygon. Okay, here we can see so many examples for polygon. These are closed figures made up of line segments. Let us start from the least sided polygon. Which is it? Three-sided polygon. Yes. Very good. Here we can see a triangle. There are three sides. We can see three angles here. So it is the least sided polygon. Here we are cutting the triangle at its one edge. We can add one more side, then it will be a four-sided polygon. Four-sided polygon is a quadrilateral. It is a quadrilateral because it has four sides. Again we are cutting at one edge and adding one more side here. Then it will be a five-sided polygon. Five-sided polygon. Yes.
Pentagon.
Yes, it is a five-sided polygon and known as pentagon. Pentagon is. As in the same manner, we can add one more side here. We can see it is a six-sided polygon. Yes, it is a six-sided polygon. Yes, it is hexagon. Very good, very good. It is a hexagon. Hexagon. So these are the classification of polygon. Yes, the classification of polygon. Can you see it? Yes. According to the number of sides, okay children, listen here. According to the number of sides, we can classify the polygons. We are starting from 3. That means the number of sides or vertices 3. Which type of polygon is this? 3 sides, Krishna?
Triangle.
Yes, it is a triangle. Yes, it is a triangle. Then there is a 4-sided polygon, that is equilateral. That family is generally known as quadrilateral.
Quadrilateral.
And five-sided polygon, that means a polygon with five sides, it is a pentagon. Very good, it's a pentagon. And a polygon with six sides, it is a hexagon. Yes, then seven sides, it is heptagon. Okay, then polygon with the eight side, it is octagon. Okay. And polygon with the nine sides, it is known as nonagon. Okay. Then
Nonagon.
polygon with the 10 sides,
Hexagon.
it is decagon. Okay. Very good, Makale. So on we can classify the polygon according to its number of sides. We can classify the polygon according to its number of sides. Sides. Okay. Now we are going to discuss about the line segment in a polygon, that is diagonal of a polygon. Listen here. The diagonal of a polygon, we can do the diagonal here. Listen here. There are 5 vertices. We can draw the line segments in the polygon by connecting any two non-consecutive vertices, non-adjacent vertices. Can you see? PR, it is a line segment. Again, PS, also another line segment here. These are line segments and these are the diagonals of this polygon. Again, we can draw line segments in this polygon from the vertex T or Q. Yes, S. Here, from the vertex, we can draw the diagonal from the vertex T to Q and R, TQ and TR, and again drawing line segments from Q to T, QT and QS. So here we can see the line segments connecting non-adjacent vertices. So here the diagonals PS, PR, SPS, Q, RP, RT, TQ, TR, TQ and TR. These are S. These are the line segments.
Diagonal.
Yes, these are the diagonals. Okay. So how can define it, Makle? Diagonal of a polygon. It is a line segment drawn. Yes, Shivanandana. It is a line segment connecting two non-consecutive vertices. Shivanandana.
Yes, ma'am.
Can you define it more like the diagonal of a polygon?
Yes, ma'am. A line drawn connecting two non-consecutive vertices of a polygon is called a diagonal.
Very good, very good. So a line connecting any two non-consecutive vertices, that is diagonal of a polygon. Is it clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Let us see. Yes. Let us see different types of polygons. There are 2 types of polygon. Here we can see it's a polygon closed figure made up of line segment. Another polygon is here. One more polygon is here. Can you see? A polygon is here. A 5-sided polygon. Yes, it is also a pentagon. But here, some speciality here. Can you watch it, Makle? By drawing the diagonal, we can see one diagonal PS. The diagonal PS in the exterior part of this polygon. Can you see the polygon in the exterior part? A diagonal in the exterior part?
Yes, ma'am.
Yes, PS. The diagonal PS in the exterior part of this polygon. Exterior part. All other diagonals are in the interior part, but one diagonal in the exterior part. So these types of polygons are known as concave polygon. These types of polygons are known as concave polygon. Yes. So we can understand whether it is concave or convex. Here it is. Every polygon either concave or convex. The difference between convex and concave polygons lies in the measurement of its interior angles. For a polygon to be convex, all of its interior angles must be less than 180 degree. Less than 180 degree. Otherwise, it will be a concave polygon. That is the important point. In a convex polygon, all of its interior angles must be less than 180. Another way to think of it is the diagonal of a convex polygon. Diagonal of a convex polygon should be in the interior of the polygon, whereas certain diagonals of concave polygon lies outside the polygon. In a concave polygon, the diagonals may be in the outside of the polygon or exterior of the polygon. So, how can differentiate this? Concave or convex? All of its interior angles must be less than 180 degree. That is in convex polygon. And in concave polygon, diagonals may be in exterior part. Is it clear, Makle?
Yes, ma'am.
Let us see some example. I will explain it. Let us see some examples here. Can you see a polygon here?
Yes, ma'am.
Okay. Okay, here we can draw the line segments or we can draw the diagonals in this polygon. We can draw the diagonals in this polygon. Listen here. By connecting A and C, A and D, A and E, A and G, and from the vertex B, we can draw the line segments or diagonals BD, BE, BF, BG and BH. These are the line segments. These are the line segments connecting non-adjacent vertices. Here also HE, also another line segment connecting non-adjacent vertices. These are the diagonals in this polygon. But can you see 4 vertices G and D and G and E, G, E, F, D. By connecting G and E, we will get a line segment or a diagonal which is in the exterior of this polygon. Can you see the diagonals in this polygon? Exterior part, diagonals lying in exterior part.
Yes, ma'am.
Which are the diagonals?
Yes, ma'am. We can see.
Yes, yes. Which are the diagonals in the exterior of this polygon? GE and FD. Yes. Yes. GE and FD are the 2 diagonals in the exterior part of this polygon. So, this type of polygon is a concave polygon. So, this is a which type of polygon is here?
Concave polygon.
Concave polygon. Concave polygon. Is it clear?
Yes, ma'am. Yes, ma'am.
Yes.
Clear, ma'am.
Okay. Now we are going to, here we can identify some polygons. So there are some polygons. This is first polygon. Can you see? There are 5 sides. There are 5 sides. Yes. There are 5 sides. When we draw the diagonals in this polygon, we can see, when we draw the diagonals in this polygon, we can see all of its diagonals are in the interior part. Any diagonal in the exterior part?
No, ma'am.
No diagonals. No diagonals in the exterior part. We can see all the diagonals are in the interior part because it is a convex polygon.
Convex polygon.
Let us take the second figure. We can see the second figure. It is also a 5-sided polygon. It is also a pentagon. There are 5 sides. It is also a pentagon. But here, when we draw the diagonals, we can see one diagonal. Can you see one diagonal in the exterior part?
Yes, ma'am.
Yes. Here one diagonal in the exterior part. So which type of polygon is this? Concave or convex? It is a concave polygon. Okay, let us consider the third figure. Here we can see the third figure. There are 6 sides. It is a hexagon. But here, when we draw the diagonals, we can see one diagonal. Here also one diagonal in the exterior part. So, it is also a concave polygon. It is also a concave polygon. Okay. Okay. The last figure. We can take the last figure. there are 8 sides.
Convex.
Yes, it is an octagon. Yes, it is an octagon. Abel, can you say this? Which type of polygon is this?
Ma'am, it is a convex.
Yes, it is a convex polygon. Very good, Mone. Okay, it is a convex polygon. Is it clear?
Yes, ma'am.
Okay. Okay. Okay, now we are going to discuss about regular polygon. Regular polygon. Here, 2 shapes here. In the first figure, we can see there are 5 sides. These two figures are 2 pentagons here. But in the first figure, there are 5 sides. Second figure also, there are 5 sides. But here in the first figure, we can see the sides are different. But in the second figure, in this figure, we can see all of its sides are equal and all of its angles are equal. In this figure, the sides are different and angles also different here. Here the angles are different, but in the second figure, we can see the sides are equal and also its angles are equal. It's a regular polygon. All the angles are equal and all of its sides are equal. Here it is a regular polygon. But in the second figure, yes, very good. It is in the second figure, it is an irregular polygon. That means its sides are different and its angles are also different. So it is irregular polygon. Here it is equiangular. Regular polygon is equiangular and equilateral. The words equiangular and equilateral, how it is connected to a regular polygon? Equiangular and equilateral.
All the sides and angles should be equal.
Yes.
All the sides and angles are equal, ma'am.
Yes, in regular polygon, all the sides are equal and all of its angles are also equal. That means all the sides are equal means it is equilateral. If the all angles are equal, then it will be equiangular. Yes, it will be equiangular figure. Okay. So here we can identify the given figure. It's a rectangle. It's a rectangle here. We know that all of its angles are 90 degree. In a rectangle, all angles are right angles. That means it is equiangular figure. Equiangular figure. But what about the sides of a rectangle?
It's not same, ma'am.
Yes, not same, not equal. We can see the sides are different. Opposite sides are equal, but we cannot say all sides are equal. So it is not equilateral figure. Is it a regular polygon?
Ma'am, it's irregular.
No, it is not a regular polygon. It is an irregular polygon. But what about a square, Maklai? In a square, all the angles are equal. Yes. In a square, all the angles are equal. Yes. All of its angles are equal. All the sides are also equal. So it is equilateral and equiangular figure. Equilateral and equiangular figures. So we can say square is a regular. Square is a regular polygon. Square is a regular polygon. Equilateral triangle also a regular polygon. Okay. Here is a question for you. What about rhombus? Have you heard about rhombus? Rhombus is also a quadrilateral. Is it a regular polygon? Is it a regular polygon? Okay, Krishna?
No, ma'am, it's irregular.
No, it is not a regular polygon because it is equilateral figure. Its all sides are equal, but its all angles are not equal. Angles are different in rhombus. So rhombus is not a regular polygon. Okay, rhombus is not a regular polygon because it is equilateral figure, but it is not equiangular. Its angles are different. Okay, now we are going to discuss about angle sum property. angle sum property of a polygon. Okay. Okay, for learn about the angle sum property, we should know what is the sum of angles of a triangle. That is angle sum property of triangle. Angle sum property of triangle. You had already learned it in 7th standard, angle sum property of triangle. Okay, angle sum property of Malavika. Can you define it, Mola? Angle sum property
Yes,
of...
ma'am.
Tell me.
All sides of a triangle will be equal to 180
Angles,
degrees.
all sides or all angles?
All sides of a triangle
All?
will be equal to 180 degrees.
All angles?
And sides of a triangle will be
No,
equal
angle
to
sum
180.
property of polygon. Angle sum property of a triangle. Here we are going to discuss about angle sum property of polygon. We should know the angle sum property of triangle. The sum of, what will be the sum of angles of a triangle, Malavika?
Ma'am, it will be 180 degrees.
Yes, it is 180 degree. That is angle sum property of triangle. So, Malavika, define it.
Yes, ma'am.
What is
All
angles?
angles of a triangle will
The
be
sum
equal
of
to
all
180
angles. Please say it.
The
Mola.
sum of all angles of a triangle will be equal to 180 degrees.
Ah, yes, very good, very good. The sum of all angles of a triangle is 180 degree. That is angle sum property of triangle. Okay, let us do an activity for proving this. Here one triangle, we can see one triangle here. It is an acute angle triangle. There are three angles. There are three angles here. Angle A, angle B and angle C. Now we are going to cut these three angles. Yes, we are cutting these three angles. And there are three angles, angle A, angle B and angle C. We are cutting these three angles and placing in the shape of a protractor. Can you see? Angle A. Okay. Again, let us take angle B. It's angle B. Then we will take angle C here. Angle C here. Pasting like this. Okay, this is in the shape of a protractor. The sum of all angles is 180 degree. Here we are taking another triangle. It's a right angle triangle. Let us check the sum of these three angles also 180 degree. Okay, here three angles. We are pasting these three angles here. Here also the shape is like this. It is also 180 degree, angle A plus angle B plus angle C, 180 degree. Another triangle, it is an obtuse angle triangle. Let us check what about the sum of angles in this triangle. Here we are pasting these three angles here also. Yes, we can see the sum of these three angles is also 180 degree. So what is the sum of three angles of a triangle? That is 180 degree.
180 degree.
180 degree.
180
That is,
degree, ma'am.
very good. That is angle sum property of triangle. In any triangle, the sum of all angles is 180 degree. That is angle sum property of triangle. Okay. Let us apply this property in polygons. Here we can see the starting from a quadrilateral. Here we can see a quadrilateral, a four-sided polygon. Can you see a quadrilateral here?
Yes, ma'am.
Yes. Okay.
Yes, ma'am.
Okay, here for finding the sum of interior angles of quadrilateral or a polygon, we have to draw diagonal from any one vertex, not from all vertices, from any one vertex to its non-adjacent vertices, Here we can draw only one diagonal like this from one vertex to non-adjacent vertices, because we know that here there are four vertices. C and A are the adjacent vertices of B. Only one non-adjacent vertex here. Which one? D. D is the non-adjacent vertex. So we can draw one line segment here, that is BD. By drawing the line segment BD, we can divide this into two triangles. So here we are dividing the quadrilateral into two triangles. And can you see this? The number of sides are 4, because we know that in a quadrilateral there are 4 sides. How many triangles formed here? There are two triangles. There are two triangles. Then sum of angles of these four angles. That is two triangles. In one triangle, the sum of angles is 180 degree. So in two triangles, what will be the sum? It is 2 into 180. 2 into 180. But yes, it is 360 degree.
360 degree.
360 degree. Very good. Oh, so the sum of interior angles of a four-sided polygon or quadrilateral, that is 360 degree, because here only two triangles. In one triangle it is 180 degree. There are two triangles, so 2 into 180 is 360 degree. Is it clear, Makle? The sum of interior angles of a quadrilateral, it is 360 degree.
Yes, ma'am, it's clear.
Now we are going to check a five-sided polygon. Yes, it is a pentagon. Here we can see how many vertices? 5 vertices and 5 sides here. Okay, by drawing diagonals, we can see A and C are A and C are the adjacent vertices of vertex B, and E and D are non-adjacent vertices of compared to vertex B. So here we can draw the diagonal or line segment. Diagonal is a line segment connecting non-adjacent vertices. Here we have to draw diagonals from any one vertex, to its non-adjacent vertices. So BE and BD are the possible diagonals here. BE and we are drawing diagonals from any one vertex to its non-adjacent vertices. Okay, here we are selecting vertex B, and by connecting E and D, we can divide this pentagon into 3 triangles. How many triangles formed here? There are 3 triangles. Okay, in this pentagon, yes, in this pentagon there are 5 sides. It is a 5-sided polygon. And how many triangles formed here? How many triangles formed here? There are 3 triangles. There are 3 triangles. Yes, there are 3 triangles. So in one triangle the sum is 180 degree. So what will be the sum of 3 triangles? What will be the sum of all angles in this pentagon? That is 3 into 180. Yes, very good, very good. That is 3. We can see here the number of sides. There are 5 sides, and number of triangles formed here, it is 3. So the sum of angles of this pentagon is 3 into 180. 3 into 180 is 540 degree. 540 degree. So here the sum of interior angles of a pentagon is 540 degree. Is it clear?
Yes, ma'am.
Yes, ma'am.
The next polygon, which one is? Yes, it is a hexagon. Here also we are drawing, very good. Here also we are drawing diagonals from any one vertex. Here we are choosing vertex A, diagonal. Okay, we are drawing diagonals from vertex A to its non-adjacent vertices. So we will get the diagonal AE, AD and AC. These are the 3 diagonals here. So we can divide this hexagon into how many triangles formed here?
4 triangles.
1, 2, 3, 4. There are 4 triangles formed. In this hexagon. So what will be the sum of angles in a hexagon?
180 into 4.
Yes, 4 into. Very good, very good. 180 into sum of all interior angles of this hexagon is equal to 4 into 180. What is 4 into 180? You can calculate it. 4 into 180 is, yes, we can see it is 720 degree. Yes, 180 into 4, that is 720 degree. So the sum of interior angles of a hexagon is 720 degree. Okay, 720 degree. Okay, now we are going to generalize this. How can generalize angle sum property of polygon? We can work out the angle sum property of any polygon. We can work out the angle sum property of any polygon by splitting it into triangles. But we should know the sum of interior angles of a triangle is 180 degree. We know that in a triangle the sum of interior angles is 180 degree. In a quadrilateral, there are 4 sides. How many triangles? 4 minus 2. There are 2 triangles formed. There are 2 triangles formed. So, the sum of interior angles is 2 into 180. Number of sides, there are 4 sides. And by drawing the diagonal, there are 2 triangles. So, 2 into 180 is 360 degree.
360.
Yes, 360. Then in a pentagon, there are 5 sides here, and the triangles formed 3 triangles. 5 minus 2 triangles. 5 minus 2 triangles here, and 3 triangles. So 3 into 180 will be the sum of interior angles. 3 into 180. 3 into 180 is 540 degree. It is 540 degree. Again, we are going to hexagon. We can see in a hexagon there are 6 sides and number of triangles formed. There are how many triangles formed? There are 6 minus 2 triangles, that is 4 triangles. So 4 into is 180, 720. Yes, let us check heptagon. Is 7-sided polygon here. Heptagon. How many sides here? There are 7 sides.
7 sides.
Yes. There are 7 sides and triangles formed. How many triangles when we draw the diagonal?
5.
5 triangles. Very good. 5 triangles. So 5 into 180, it is 900. In the case of an octagon, it is 6 into, because there are 8 sides. So 8 minus 2 triangles formed there. So 6 triangles formed there. That is 6 into 180. What is 6 into 180? It is 1080. So the sum of interior angles of an octagon is 1080. If the polygon, if the polygon has n sides, then there will be n minus 2 triangles inside it. A polygon with n sides contains n minus 2 triangles. Like this way, we can divide it into n minus 2 triangles. A polygon has n sides. There will be n minus 2 triangles inside it. By drawing diagonal from one vertex to its non-adjacent vertices. From one vertex to non-adjacent vertices. Okay. Tell me, Mola.
Ma'am, n minus 2 into 180 will be the sum of the interior angles?
Yes. N minus. Yes. Very good, Mola. Very good. Here I am going to discuss about it. Very good. Yes, we can generalize the formula like this. Very good, Mola. Here we can see the triangle. There are 3 sides. So 3 minus 2 into 180. That is 180. 3 minus 2 is 1. 1 into 180 is 180. In a quadrilateral, it is 4 minus 2 into 180. What is 4 minus 2 into 180? Is 2 into 180, 360 degree. In the case of a pentagon, it is 5 minus 2 into 180. 3 into 180 is 540 degree. And in hexagon, it will be 4 into 180. Yes, it is 720. There are 6 sides. You should remember there are 6 sides. So the triangles formed 4 triangles. So 4 into 180 is 720 degree. So we can generalize this formula. Polygons with n sides. Very good. Here sum of interior angles of a polygon with n sides. What will be the sum of Maheshwar Raj? Tell me. The sum of interior angles of a polygon with n sides.
Can you tell the question once more?
The sum of interior angles of a polygon with n sides. If there are n sides, let us assume there are n sides. Then how sum of interior angles What will be the sum of interior angles? N minus. What will
N minus 2 into 180.
Yes, very good, Mona. It is n minus 2 into 180 because we know that in a triangle there are 3 sides and the sum of interior angles is 3 minus 2 into 180, that is 1 into 180. And in a quadrilateral there are 4 sides, so 4 minus 2 into 180. Okay, we already discussed about it. Yeah, so in the polygon with the n sides, what will be the sum? It is n minus 2 into
N minus 2
180.
into 180 degree.
Where n is the number of sides of the polygon. Okay. Where n is the number of sides of the polygon. Is it clear, Maklai, this concept? The sum of interior angles of a polygon.
Yes, clear.
Okay, very good, very good.
Yes, ma'am, it's clear.
Tell me.
Ma'am, does it matter if it's a concave or a convex polygon?
Is in the case of convex polygon, because we are discussing about convex polygons.
Okay, ma'am.
Can you see? Can you identify this triangle? We are discussing about triangle, quadrilateral. All these figures are convex polygons, Mone. Is it clear?
Yes,
Is it
ma'am.
clear? Okay. Okay.
Yes, ma'am, it is clear.
Okay. 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 Are you ready? Now we are going to discuss some problems. Are you ready?
Yes, ma'am.
Ready, ma'am.
Okay. We can apply this formula.
Ready.
Okay. Okay. You can write. You can write this question in your revision book.
Yes.
Okay. Okay, the question is this. Find the sum of interior angles of a polygon with 10 sides. Find the sum of interior angles of a polygon with 10 sides. It is given. There are 10 sides. So we can apply the formula. Sum of interior angles of a polygon with n sides, that is n minus 2 into 180. Okay.
Ma'am, I got the answer.
Oh, very good, very good. Don't call out the answer.
Nice.
Don't call out the answer. Let us see the answer. Did you complete? Okay.
Yes, ma'am.
Okay, okay. There are 10 sides. So we can apply the formula n minus 2 into 180. Because we know that the sum of interior angles of a polygon with n sides. It is n minus 2 into 180. Here it is given there are 10 sides. Which type of polygon is this 10 sides?
Decagon.
Very good. Very good. Decagon. Oh, yes, very good. Decagon. So the sum of interior angles is 10 minus 2 into 180. What is 10 minus 2 into 180? 10 minus 2. Okay, we know that it is 8. 8 into 180. Find the product. 8 into 180.
1440.
Very good, very good. The answer is 1000. Okay, I hope you all got the correct answer. 1440. Is it your answer? 1000.
Yes, ma'am.
Very good, Maklai. This is the correct answer. 1440. That is the sum of interior angles of a polygon with 10 sides. Are you ready? Can I go to the second question? Okay.
Yes, ma'am.
Okay, this is a question. Please write it. Find the sum of interior angles of a polygon with 8 sides. Polygon with 8
Got
sides.
the answer.
Okay, okay, very good, very good. Don't call out the answer. Wait. We will explain the answer. Okay. Please do the question, Maklai. Find the sum of interior angles. Let us see the answer. Sum of interior angles of a polygon with 8 sides. With the polygon with the n sides, we know that it is n minus 2 into, very good, Mola, wait. A polygon with the 8 sides, that is 8 minus 2 into 180, because we know that in general it is n minus 2 into 180. Here it is 8 sides, so 8 minus 2 into 180. What is 8 minus 2 into 180?
Ma'am,
6.
6 into 180.
Very good. 6 into 180. Very good, Maklai. It is 6 into 180. The answer is 1080. You got it?
1080, ma'am.
Very good. 1080. You got it?
Yes,
You got the
ma'am.
correct answer?
Yes, ma'am.
Yes, ma'am.
Very good, Maklai. Here, the sum of interior angles of a polygon with 8 sides. That is 8 minus 2 into 180, because we know that the sum of interior angles of a polygon with the n sides. In general, we can say the sum of interior angles of a polygon with the n sides, that is n minus 2 into 180. we can apply this formula here. Here it is given the number of sides is 8. So in the place of n, we can substitute 8. That is 8 minus 2 into 180. It is 6 into 180. 1000, 1080. Okay, is it clear?
Yes, ma'am. Clear, ma'am. It's clear. It's clear.
Okay. Okay, this much today. So what all topics we discussed here? Polygon. Okay. Geometrical.
Concave and convex polygons.
Okay. Okay, wait. Okay. Okay. Okay.
property.
Okay. Okay, Makle. Here, starting from polygon, different types of polygons. We have discussed what is polygon. We can define polygon. Polygon is a closed figure made up of only line segments. And the classification, then we discussed the classification of polygon. We can classify the polygon according to its number of sides and the diagonal of it. There are two types of polygons. We also discussed the two types of polygons, that is convex polygon and concave polygon. Diagonal of a polygon, it is a line segment connecting any two non-adjacent vertices. And after it, we discussed the sum of angles of a polygon, sum of all angles of a polygon. That is according to its number of, it is related to its number of sides. Okay, that is n minus 2 into 180, where n is the number of sides. Is it clear?
Yes, ma'am. Clear.
I hope you all understood this topic.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Okay, Makle. Okay. Okay, today we have to wind up here. If you have any doubt, you can stay here. Otherwise, you can exit.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am. Have a nice day.
Okay.
Thank you, ma'am. Have a nice day.
Thank you. Thank you.
Thank you, ma'am. It was a nice
Thank you.
Thank you, ma'am. Have a nice day.
Thank you. Thank you.
ma'am. Have a nice day.
Thank you. Thank you, Makle. Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, Makle.
Thank you, ma'am. Have a nice day.
Thank you. Thank you, Makle. Same to you. Same to you. Thank you.
Ma'am, have a nice day. It was
Okay.
a very interesting class.
Thank you, Makle. Same to you.
Thank you, ma'am. Ma'am,
Thank you,
today's
children.
evening class is yours.
Yes. Can you repeat?
Today's
Repeat.
evening class is yours. Today's evening class is yours.
No, no, Mole. No.
Okay.
Thank
you, ma'am. Have a nice day. It was very
Okay.
interesting.
Thank you. Thank you. Thank you, children. Thank you.
Thank you, ma'am. Have a nice day.
Thank you. Thank you, Makle. Same to you, Mole.
Can we exit, ma'am?
Yes, you can exit.